Hello everyone, welcome to this session on autoregressive processing. In this video, we'll understand what autoregressive processing means, how it works, and why it's such a core concept in modern artificial intelligence and natural language processing models. Let's start with the basic idea. The term autoregressive comes from two words, auto meaning self, and regressive meaning using previous values to predict the next. So, autoregressive processing refers to a method where a model predicts the next value in a sequence using its own previously generated outputs. In simple terms, it learns from its past predictions to make future predictions. To understand this better, think of writing a sentence word by word. When you write, each word depends on the words that came before it. For example, if you start a sentence with, "The cat sat on the," your brain naturally predicts the next word might be mat. That's autoregressive thinking, predicting the next step based on previous context. In machine learning, especially in language models, autoregressive processing works like this. The model takes a sequence of tokens, let's say words or parts of words, and predicts the probability of the next token. Mathematically, we can describe it as p x1, x2, dans n stir dan x n, and skir ans, p xt, ans x1, x2, and c xt1. This means the probability of the entire sequence equals the product of probabilities of each token, given all the previous ones. Each step depends on the history or the previously generated tokens. Modern large language models like GPT, generative pre-trained transformer, or other transformer-based systems rely heavily on autoregressive processing. Here's how it works in simple terms. 1. The model reads the input text. 2. It predicts the next token or word based on the context. 3. That newly generated word becomes part of the context for the next prediction. 4. This continues until the model decides to stop, for example, when it predicts an end-of-sequence token. This step-by-step prediction process is what allows these models to generate coherent and meaningful sentences. Autoregressive processing isn't limited to text. It's used in many fields: language generation, chatbots, content creation, translation, and summarization. Speech synthesis, predicting the next sound wave segment to generate natural-sounding speech. Time series forecasting, predicting stock prices, weather data, or energy usage based on historical patterns. Image generation, models like Pixel RNN or Pixel CNN generate images pixel by pixel using autoregressive techniques. Strengths, produces high-quality and context-aware outputs, handles sequential data effectively, allows flexible step-by-step control in generation. Limitations, slower generation because it predicts one token at a time. Errors can accumulate. A small mistake early on can affect later predictions. Difficult to parallelize compared to non-autoregressive models. Researchers are exploring ways to make autoregressive models faster and more efficient. Techniques like parallel decoding, mixture of experts models, and speculative sampling are helping to speed up generation without losing quality. While some new approaches like non-autoregressive models are being developed, autoregressive processing remains the backbone of many state-of-the-art AI systems today. Let's summarize what we learned. Autoregressive processing means predicting the next output based on past outputs. It's fundamental in language models, time series forecasting, and generative AI. Despite some limitations, it's currently one of the most reliable and effective methods for sequence generation. And that's all about autoregressive processing. I hope this session helped you understand the concept clearly and its importance in modern AI systems. If you found this educational, make sure to explore more about transformer architectures and non-autoregressive models. They're the next step in understanding how machines generate intelligent sequences.